Safe. Howdy hi. Happy Thursday. Oh yeah, look, I've got this other chair now. Need to sort it out. Oh yeah, it's just going to be sticking out. Oh no. Wait, I'll work this out. Maybe it should be round that way. Oh, there we go. That's the answer. I've just well, that'll do. I've set up a couple more PCs in here now, so that I can play multiplayer games with my kids. How nice is that? So they got a nice surprise waiting for them when they get home from school, but that's not what we're doing right now. What we're doing right now is AQUABOY. And there's a very specific thing to work on today. Yeah, which I had a good think about last night. So I think I know what the plan is. So we're just going to try and pull it off, basically. I've got a couple of hours. Yeah, I've got a couple of hours. So we'll do like sort of 2 hours on this and hopefully we'll get it going. So what we're doing is we're going to try and get the water to know when it is electrified. So I'll show you the little sort of test environment that I've built for us to kind of get this mechanic going in. The puzzle here, you know, quite simply, is going to be power the water and let the water, you know, connect the circuit. Now, obviously, if we were actually in this water right now, we would die. So there's also, leading on from this, this is the first thing that we might want to start thinking about implementing: the player taking damage. You know? I think so. Scrap, how are you? Good morning. Good morning, sir. Yeah, so we need all of this water to know that it is now powered. Basically, the water needs to get involved in our circuitry mechanics so that, you know, you turn this off, you turn it on, the water's going to change yellow or blue or something. I think for now, debug-wise, we'll just go yellow. But yeah, this would be a cool puzzle, right? And something we definitely want in the game. With the game being about water and physics and the circuitry, the whole point in the circuitry was always about having water that's charged or not, and having water kind of, I mean, water can be like a splitter, right? So if you've got one power source but three things you want to power, then there could be puzzles where you use the water to power the water and then have 3 or 4 cables coming out of the water. So it's like a splitter. Commander Keen vibes, sick. That's a good compliment. I am also that old to remember Commander Keen. Oh yeah, and that was the other thing I was working on yesterday, is these cables now. If you try and stretch them too far, he just drops them. You can get to about there, any further, and he's like, and it's like the cable's like, no, I'm having none of it, mate. It all seems to be working. So back to that mirrored board then. This is not the best picture, but it makes sense to me. So I'll talk you through what I was discussing last night and planning last night. Cesare, hi, what's up? How are you? I'm good. I'm good, thanks. Yeah, I'm having a happy Thursday. coming to the tail end of a week off work, but I've been making loads of progress on the game. So no, I'm good. How are you, Cicero? I hope I'm pronouncing that vaguely correctly. I hope you're well. Okay, so if we imagine, let me draw this again actually, because it might be easier to just see. Let's say our level is like this. Okay, I'm trying to draw it on the grid here. And we have like a cable that's hanging into the water there. And then we have another cable and it's hanging into the water here. And the water's like that. You just followed. Oh, thank you very much. Much appreciated. Thank you. I hope you don't regret it. I'm going to be streaming a lot this year because I'm making this game. I'm going to put as much time into it as I can. So most weekdays we should have a stream. So I think you've made a good investment there. So then what would happen is like the power is here, and we make this the end of this cable here. When it's in water, it's going to be saying, "Hey, I'm in water," and sending a request to the water to propagate electricity. I suppose only if this is powered as well. Of course, the cable itself must be powered. But if it is, then it's going to tell the water, look, I'm charging this cell here that I'm in. Send charge to its neighbours. And then take those neighbours and check if its neighbours are in water. Now, these ones aren't, so it wouldn't do anything with those. But that one is, so it'd send it there. This one isn't, this one isn't. So this guy wouldn't send anything there, but it would send it to the water there. And this one would, see that it's already been sent to those ones and send it here. And then these guys would equally do that and do that. And this, doing an algorithm like this will ensure that the entire body of water is notified that it's powered now. And of course, then this guy being a receiving cable will be constantly checking. It's saying, look, I'm expecting to be powered now and I'm underwater. So, am I powered? And it would then see that it is, because this charged property will have gone through the grid of water, right? Now, how do we stop it? Because if they always pass it on, that's a problem. But maybe they don't always pass it on. Maybe this guy leaving, when he leaves, that's when he'll like send a signal through. But I actually think a better method is what this drawing is up here, which is that at the start of a frame, we tell all water particles that they are not powered. And at the end of that specific frame, that is when this guy sends the charge. So in fact, maybe it could just be when this guy sends the charge, the first thing it does is reset them all. But I think what we do is we just probably reset every water cell on the map. One in every 5 frames or whatever it is. And if this guy's charged at that point, then we run this function that repropagates it. And then we just leave it for, say, 4 frames. We can change how many frames we leave it for before we do this again, based on performance, based on what we can get away with. And then that ought to do it, because then once this guy leaves, every 5 frames or so, it'll just get reset. They'll all just turn off. So that should work just fine, I would have thought. That's the plan. Let's see if we can make it happen, I guess. So yeah, I mean, should we just get going? I guess it's time to start writing this code. So where to begin? I suppose let's first try and turn whichever cell the cable is in charged in yellow. So let's do that. So we're going to need to get back into our water scripts here. We want the water algorithm, and I think we want the water renderer too. And we want the wire pin. The wire pin is the key thing here. The pins are the things that make a difference. The wire has a property of whether it's powered or not, right, in its script. Yeah. The Grinch, hello. Greetings. Yeah, it's been a while, eh? How are you, the Grinch? I hope you are well. Wouldn't it be easier to just check if both loose cable ends are in the water and powered to enable damage? And open the door at the end of the level. Yes, except that we will have levels with multiple bodies of water. In fact, I can even show you in here in our test level. The way I've set it up is just to show off a bit of the flowing water at the beginning. But look down here. There's a whole nother body of water down here. And we don't want this water to be charged because there's cables up here. So there needs to be a way and because in the puzzles the player's going to be moving water around all the time. There's going to be taps and drains and lots of things. So we want the game to know to only charge the body of water that's connected. And also we can't, one thing I was thinking of doing was like a pathfinding algorithm instead of having to propagate the whole thing. Although I suppose the pathfinding algorithm probably does that to an extent. But there are efficient tricks in pathfinding algorithms, aren't there? And I was thinking maybe it just pathfinds from the one end of the wire to the other. And if it can make a path, then it knows, hey, I'm underwater, right? But the problem then is that the water that isn't part of that path doesn't know it's charged. And so if the player touches, you know, the whole body of water needs to be spreading the charge for the player to take that damage. So, did I open the water class? Because that's the other thing we definitely need. Because it needs to have a powered property. And it needs to have a powered color. Yeah, and do I want to make it so that we'll just have one color for now? But in the long run, we're going to change all this anyway. Should we go green, yellow? Does that feel like sufficiently electric? DOS games were much like this back in the day. I get an old game memory from this. Nice. Yeah, I mean, our plan is to definitely hit the thing. But what I should show you guys as well, because this is just cool, is the direction that the artwork's going in. There's some of it on the Miro board. These kinds of sketches like this that Pete's been doing. Of what AQUABOY... Well, actually, do you want to know a twist? It's not really a twist, actually. But AQUABOY is not the name of the character. AQUABOY is the name of the bomb, the weapon in but there's a whole story being developed anyway. But like this kind of these kind of concept sketches are really cool, right? And so we thought instead of pixel art, like this should be the art style of the game. And we do have some little proof of concept things going on here. And soon some of this stuff that Pete's been working on for the visual style, we will be porting into this main Godot project where all the features are. But yeah, let's check this out. It's pretty cool, right? And we've got like moving shadows and parallax and stuff happening. Yeah, so we're gonna have this kind of like comic book come to life with loads of modern post-processing on it. Is going to be the visual style. So all of this I'm using here, this is obviously all completely like developer placeholder bullshit art. The pixel art of the player, the character, we're probably going to keep making, because then animating in little pixels and then doing the sketches over the frames is easier than animating through sketches. We can iterate way easier with pixel art, get the motion right, and then sketch over it. Anyway, so all this stuff's happening, but yeah, there's a team of 3 of us on this year. So yeah, it's happening. Right, so the water is able to now be powered by something. So that's cool. And then we want to have the pin check if it's underwater. Just like the player does. Manage water entry and exit. I expect we want a similar scenario for the pin. We're already tracking whether it's underwater or not here. So let's make that into a function actually. Oh wait, I didn't need to wait, hold on. Just undo that. And then I think if underwater, then it should maybe what it should do yeah, I guess I'm just wondering if we want it to just tell the water when it enters and exits and then have the water deal with the rest. Or do we want this guy pinging the water every single frame? Do you know what I mean? One of the things that's going through my mind is that we talked yesterday, me and Pete as well, about this idea that like the size of the body of water could impact how long the charge lasts. After you unpower the water, it could stay powered for a bit of time, and the size of the body of water could have a impact on how long it manages to hold its charge after you've disconnected it. But that's probably something that's not that difficult to add in as an additional feature later, and I should probably not focus on that right now, I would say. So if we are underwater after we've managed entries and exits, because that's where we actually update this underwater variable, we basically say if the variable that we're holding doesn't match the truth anymore, then we need to swap. We need to switch which state we're in. So once we've done that, and then we say, well, if we're underwater now, the wire pin doesn't have a reference to the water. It does have a reference to the water. So water dot, and there's this. And we'll feed its global position in there. No. We've already done that. What am I talking about? This is where we want to do like send power or something. Water dot yeah, and then we put in. So okay, so here's the thing. When we go here, we're going to have to reuse some of this. Is that? What did I call it? Send power. Send power. So we'll feed our global position in there. And I think what we'll do is we'll just, in the water class, we just have a little timer. Whenever powered is true, whenever it's set to true, we reset that timer. Could just be a little counter, couldn't it? So they basically just keep needing affirmation that they're powered in order to maintain it. And if they don't have that, they turn themselves off automatically. And that counter's only running when they are powered. Yeah. I think that would work. So I guess they have like another variable like power decay. And that's at like 0. And then we'd say in the physics process, don't think we'll use delta for this. We'll just say if powered, although now every single cell is going to be doing this every single frame. That's fine, let's just do it for now. If it's really inefficient, then we'll work something else out. I've powered and power decay is like greater than 10, then we're not powered anymore. And power decay goes back to 0. I think that'll be fine. Okay. And then in the water algorithm, send power. We want to get the actual position. And then we want to take that and we want to say dot powered is true. And that should at least power the cell that the thing is touching. And now if we go into our renderer, if it's awake, do that. If it's asleep, do that. Wait, hold on. Then, did I call it powered in the water class? Powered color. So I think the cell should go yellow now. Yeah, okay, look, we've got yellow cells. Which I guess we can't see because it's behind the thing. Oh no, it's because it's not powered. We're only doing it to those that are awake. We want this to usurp everything, so I guess it needs to be the first if. It's like if it's powered, then the color is that, right? But if it's not powered, then you can check whether it's awake or not and set the colors accordingly. Okay. So when it's not powered, it is definitely still turning cells yellow. So that's not right, is it? And also, this is being redrawn every frame, so I would say this isn't working. I wonder if it doesn't have a physics process, if it's just... No, it should do, shouldn't it? I don't know. I mean, they're not turning back to blue yet. Something's not right. I guess let's go from the beginning. I've probably just missed something really basic. It's usually what's happened. I mean, that must be working. That is working, because we know that's working, because, like, that's working. I think this is working. I think the bit that isn't working, the only bit that I really think is not working, where is it? Is this. So hold on a sec then. Yeah. These instances of water, they are not in the scene tree. I'm guessing they're not being processed. They're just holding data inside our grid. Because we knew water like that. So we're creating this like type of item. I wonder what does the documentation say about new? It says there's no such thing. Returns a new instance of the script. Interesting. So we're just so the script, there's a new instance of the script for each water thing, but we're not like, okay. The process isn't running. As it stands, my thing doesn't actually like loop through every water. So right, if these guys can't count for themselves, that complicates things quite a bit. yeah, if this doesn't work, we've got to kind of rethink quite a lot of it, because if they can't turn themselves off because they're not actually processing, they're just holding data, which is kind of good. That's probably what we want. That's probably why it's working. If we made these actual nodes that were in the tree that were being processed, that would probably be a bit crazy. So let's get rid of all of that. We just have our powered for now. We need to find a way of turning them off in here. I mean, if I tick process full grid, I think everything will be much slower. It still seems okay with process full grid off. Seems about the same. Also though, it's like, it's not working because it's doing it. Let's solve the problem of the fact that it's doing it even when it's not powered, because that shouldn't be happening. Oh, it only does it whenever it's underwater. If underwater and powered. There you go. Perfect. Okay. Easy fix for that one. Ants, how are you? Welcome. Shout outs to you. So in the process, whether we're processing the whole grid or not, this is something we do need to process on the whole grid. We're going to do a function called reset power. Now we need to loop through the whole grid, which we probably have. So we use it when we're processing the whole grid there. And we use it right at the beginning. And it gives us a shuffled list of all the fluid cells. For our purposes, they don't need to be shuffled, so I think we can be more efficient by just copying that code. We don't care if it's awake or not, we care if it's powered. We don't need to store them anywhere. So I think running that every frame will do it. Might make everything a lot slower. It feels noticeably slower. And I can't tell, so I guess it's only being powered for like a frame or something anyway. And the thing is I don't want to do this every frame. I wonder if there's like a sneaky way of doing something every 6 frames or every 7 frames rather than do every 5 frames. I mean, a timer would do it. God, there's so much mess. Let me just turn everything off apart from what I need, which is the process. Probably will need get neighbors in a bit. And that looks like it does all 8 neighbors, which is cool. Keep send power open. Okay, that makes the script a lot more manageable to scroll up and down in now. Cool. So I think we want to do this like once a second, maybe. So we'll get the water scene up here. So we're going to add a node to it. We're going to add a timer. And we'll call it power reset timer. And we'll make it be every second. And we'll make it auto start. And we'll take reset powered out of there and we'll put it into a timer here. And then see what that looks like, how that plays. Looks good. And instead of it being every second, we'll make it every 0.2 of a second or something. So it feels a bit more responsive. Oh, it's not powered. And if we leave it still, you can actually see kind of flashes once every 5 frames, or every 0.2 seconds. For purposes for now, I think it should be okay. Now we want to make this guy go crazy, so it's going to use get neighbors to like propagate it. So it outputs an array, we give it a cell, a vector 2i, and it does one above, one below, one to the right, one to the left, and the 4 diagonals, and returns those 8. Those 8 cells. Okay. Yeah, so there's a bit of a thing to do here. What do we want to do? Firstly, we power the cell. We'll try and write it all in this function, but no doubt we'll get to points where we want to loop some code, and we'll make some breakout functions as well. I'm guessing. But we want to power the cell that we know this is only being called because the position of the pin is underwater. It needs to be powered, but it needs to be unplugged as well. I've just thought it's not good enough to just say, is it underwater and powered? Because something plugged into the wall underwater. Well, actually, yeah, maybe to be fair, yeah, that's fine, actually. What am I talking about? That's fine. If there's a plug plugged in and that whole thing is underwater, then the water's charged. Yeah, that's cool. Okay, so back to here. So if it's true, and then we want to say get neighbors of water position. And then we want to like loop through them. And for each one we want to check, have we seen this cell before? So there's a few things that we want. We want like somewhere where we keep track of processed cells. An empty array. We want somewhere Is that it? What am I doing? And sorry, if current frame cell X, cell Y, I guess we need to check if it's water first. If where was it? That's what I want. I want a version of this. If not, process cells has cell, then we're going to process it. Else, Yeah, we don't even need an else. We just do nothing if not. Then we, if it's not in the list of processed cells, then add it to the list of processed cells, and then check if that cell is an it has water, which I think is this. We're going to do all this in the current frame, the sending of the power, because we want it to happen as soon as possible, right? I might want to change these to next frame and be editing the next frame value instead. The problem is we don't know if this is being triggered by something else. We don't know how far through the process. Anyway, well, let's just blindly carry on and see what happens. So if it's water, then it's now powered. And because it's a water cell that is now powered, we have to add it to the process queue. We get the neighbors of the one that we've just powered, right? And then we look at all its neighbors. And if we've not seen it before, then we check if it's water, and if it is, we power it. And at that point, we want to do this to it. Have I got a warning? I haven't used process queue yet, okay. We don't want to just add all its neighbors to the queue though. We want to check its neighbors against processed cells. We want to basically say, like, look at its new neighbors. Look at all of its neighbors that we've not seen before. And do something with those. Init. I think that makes sense. So, but I think we need one of these recursive functions, don't we? Where it like calls itself in itself until it's all done. For now, I guess this is going to power the neighbors as well. Yeah, it powers all the neighbors. That's pretty cool. The flashing every 0.2 seconds isn't ideal, is it? Instead of this being a timer here, I wonder if you just do it every time before send power gets called. We'll think about this a bit more. But for now, we still need it to actually iterate through the whole body of water. But I mean, whatever happens, yeah, like we're pretty sure that at this point, that cell that we've just turned to be powered, because it's not one we've seen before. It is water. We make it powered. Now we definitely need to do this to that one. So it's in the process queue. So after we've done this, this is like the initial, this is the action we do to the initial cell. So I think is it a while loop that we need now? Then we just say while, after we've done this, the next thing to do is to say like while, I need to remember how while loops, what the syntax is. Syntax. It's not going to be in the documentation, is it? Let me just have a quick. Is this like a slightly more complicated? Okay, yeah, it's simple enough. We just while and then a statement, right? So while dot size is greater than 0. Oh, size is a function. Cell is process key 0. Then we'll take process queue. Not remove. Is remove the right thing? I can't remember what it's called. That's finding and removing something. No, we just want to remove an element by index. Use remove at. Removes the element array at the given index position. Yeah, this is it. That's what we want. Remove at 0. Oh, wait. Is that the position is the int? Yeah, so that's a method. So now we've grabbed the vector that's being stored in the process queue. We can remove it at the end of what we've done here. And what we do to it is this. No, we want to get its neighbor. We want to loop for the neighbors. So we want to do this to it. For neighbor. Why doesn't it like water position? Oh, I see. All of this needs to come forwards. And then we still need to put neighbor and neighbor there. And append the neighbor. Is that gonna do it? No. I wonder why not. Oh, because I'm still using the neighbors of the water position for neighbors in get neighbor cell. Okay, that's pretty good. That's looking pretty good. And it doesn't particularly crap its pants. Like, I mean, the flashing is horrible. So we need to change the way we're managing it being reset. Also, isn't this guy sending it every single frame? That is overkill. But interesting that we're running that code every frame and it's fine. I'm sure I could make this tidier, but it does work and it does make sense. I just think we could probably condense this into our while loop from the very beginning. Wait, don't we just... We make the process queue and then we just add this cell to the process queue. Because then the first thing it's going to do is... It's just going to do that. So I think we can delete all of this and just say process queue dot append cell. And so we start by Oh yeah, not cell. Water position. Should just work exactly the same as it did before. Yeah. It's pretty good. Pretty good start. Semtex from Metal Gear. Yeah. Was that the one where you had the spray that you had to freeze the bombs? That was Metal Gear 2. No, weren't they C4? That was disarming a load of C4 with the spray, wasn't it? Oh, I can't remember. Great games, though. Particularly Metal Gear Solid 2. That one just... I remember loving the first one, and then when the second one came out, and I was a bit older as well, so like got into the story a little bit more, just blew me away. Anyway... surprisingly efficient, that is, actually. Right. So... I really don't like this. I'm trying to think if there's a good reason. No, yeah, the cells need to be able to depower themselves. They do. I've thought this through a few times, but they do, because otherwise the player could take some powered cells and then separate them from where the wire is entering and exiting, and then the power wouldn't... Yeah, no, that wouldn't work. So I think we do need the cells to automatically reset themselves at a certain point. How about it runs reset powered whenever there's a frame where send power was not called? So what we need to do is we need to have some variable that this guy resets. This is the physics process. That seems unnecessary. Let's do this in the process. That will also help. It's so good. Oh, and by putting it into the process now, we get what we wanted. It doesn't flash. And it does turn off almost immediately. Within 0.2 seconds, the power turns off. That's not bad, is it? And then... well, what if this was being run every frame? It's definitely hit the frame rate. That's definitely hit the frame rate. Okay, good to know. Because the thing is with that one, that is going through the entire grid. Oh, what did I just do? I don't mind the 0.2 seconds, to be fair. I actually think that is fine. So now we just need this guy to know. I think we need to be able to add the throwing of wires as well. not just placing them on the ground. They need to be throwable. So if you're underwater and you're powered, then you're sending the power, right? Else you're just underwater, but you're not powered. You might want to check if you can be. So we have resetting the powered, we have a send power. I think it makes sense probably to put it in between here, to put a function called check power. And we'll feed that a global position. And we'll spell that funk instead of fucking. And we'll do this straight away to get a position in the water from the global position again. And then we will say if the current frame power is true, well, then we need to send. I guess what we want to do is have the global position. We want to have the wire pin being fed in as well. Not there. Check power, self, and global position. Oh, what are you sad about? Okay. And then if it is powered, if the water's powered there, then the wire pin parent is powered. Is that going to be enough to do it? I don't think so, because I think it will turn it green, but I don't think it will open the door yet. It didn't even power the cable. Yeah, unfortunately I was just hoping that the cable would turn green, but it hasn't. I think we need to use the turn on instead of just saying that it's powered. That's not how these things work. It's this. Yes. Yes. Oh, yeah. But look, we have an infinite loop of power, because now I can turn that switch off and it does fuck all. How do we stop this? Because they're both powering each other. So you come out of the water, and you come out of the water, and then does everything stop finally? The water stops being powered. The cable stops being powered. This one is just eternally powered. It does. It's just like an infinite power cable. How funny. I've not been able to do that with anything else. Okay, so there's some logic here to do, which won't be particularly fun, I don't think. What about turn off like that? So whenever a pin exits the water, whenever it's not in the water, it's off. Oh no, we don't want it to always be off whenever it's... Yeah, that would just break everything. No, that's stupid. I think that what we want is we just need some logic in here about whether or not what type of cables they are. Like, we need to get our head around the polarity thing. And how the water kind of plays with that, you know? It's going to be just a little bit of fiddling around. So it will only work with pins that are detached. which is this interactable thing, isn't it? It freezes it, makes it interactable. So in here, we could be setting like a bool for like unplugged. I don't really know. Right, so by default they're attached. Okay, so therefore in here unplugged should be false by default, and then we'll set it in here so when they become interactable that means they are unplugged, and when that's like that, so now we know when it's unplugged. We can say if you're underwater and you're powered and you're unplugged, and you are ascending end. That's the thing, we need to know if it's ascending or receiving end. And that's something I need to get my head around, because it's all being set in here. Oh yeah, doesn't like that. Put that powered one first and underwater unplugged. Powered, underwater and unplugged. If you're just underwater and unplugged, then you should check. But I want to only do this if this guy is set up to be a sender. Sorry, hold on a moment. Very loud ringtone. Okay, all right, we're back. Although that said, I'd have to go in about 10 minutes anyway. But let's see if we can get this. If we can get this just quickly sorted, it would be great. And I think we can just do it by editing these 2 lines of code. We just want to make sure that they're actually eligible. They're properly eligible to send and receive. So we're now checking that they're definitely unplugged, which is good. But then we also want to check that is the right end of the wire. And we do have pin A is send. So what we want is the pins. Oh, they know what pin they are. Because that's set to 0 and that's set to 1. So they already know what one they each are. So we just have to check if pin A is send. Which by default is true, which is kind of weird. We don't have a way of holding a state for the wire where it's ambiguous. That's the thing that I think actually we might need to formulate a bit more, or formalize a bit more. Yeah. Yeah, so the way that we initialize wires that are already plugged in is here. So this is crucial. So the plugged in, there is a call on plugged in. We start the simulation, we plug in the thing, and we detach the pin of the other one. We always plug in 0 by default. So any plug that starts like that, okay, defaults with 0. Pin 0 is plugged in and pin 1 is out. That doesn't mean that it's always sending or receiving though, because it depends how the socket is set up. So we do this. We take the wire and run plugged in on that. We set it to be the plugged in thing, which it already is if it's one of those initializing ones. We feed the self and we feed whether the player's holding. So then wire plug-in happens. And this is where we check what the kind of polarity is. And therefore set the pin A, pin B thing. Now, so that's fine. So anything that's already plugged in will know. It will know whether it's good to go or not. What about one that starts unplugged? We just detach them both. And pin A is send will be default. By default, like, that's the way round it will be. But if it's unplugged on both sides, it's never going to be powered. So it simply won't matter. So then, to say if the wire is powered and it's underwater and it's unplugged, if it's powered, it must be plugged into something else that is powered. So if you're essentially you're not powered, because that's the only difference in these two if statements. Let's make this easier. Let's just start by only checking things that are underwater and unplugged, and then we can just say, well, are you powered and are you not powered? I think that one's totally fine. Now, if you're not powered, you want to check it's like this. If not powered, then are you unplugged on both ends? If so, then change this underwater end to the receiver, and then get powered. Else, are you only unplugged on this end? The looping thing might still happen. Yeah, it's tricky because of this, because making the cable powered means it then starts to contribute to the powering of the water it's in. Even though it's getting its power from that water, it will start powering it. Yeah, I need to think about this for a bit longer, I think. Oh, interesting. Of course. When the player's holding it, our unplugged checking doesn't work. We need to also be checking if the player's holding it or not. Because if the player's holding it, then it still counts as being unplugged. Yeah, I guess it's more about these functions than it is about these ones that attach and detach the pin. What we want is we want the ones at this level. But actually, whether it's unplugged or not doesn't make a difference to us. You know what? It doesn't make a difference because we want stuff that's plugged in to still. So we just get rid of unplugged altogether. It's not important for our purposes, actually. It's kind of, that's not the point. The point is like how it's oriented and where it's getting its power from. That's the puzzle I need to resolve. Noticeable slowdown of frame rate there while all that's happening. Yeah, there's lots of like looping code going on, I think, because both of them are going to be running this every frame and stuff now, and yeah, doesn't quite work yet. I think I'm going to let this swim around in my brain for a bit longer, and yeah, shorter stream today. Still done over an hour and a half. Want to just make progress every day. Yesterday was a big one. We did like 4.5 hours. I had quite a lot to do this morning, but tomorrow I don't have so much in the morning, so I'll probably do a longer one. And I just need to let this go around my head a bit tonight, I think. But thanks for watching. Big up yourselves. Shout outs. Happy Thursday. All the rest of it. And I'll catch you soon. Yeah, all right. Be excellent to each other. Peace.